Welcome to chapter 15. We're going to stop talking about genetics. Seems like we spent a long time on that. We're going to talk about nutrients and their functions. I'm pretty sure this chapter is probably going to take me 2 recordings to get through. We'll see. Okay, so first of all, something to remember about livestock is that they don't eat the same thing humans do. Thank goodness. So one of the differences between livestock, especially the ruminant animals, is they can consume a lot of roughages. So roughages are things like hay and baled grass hay or alfalfa. And I think it's kind of interesting. These are round bales. We don't see these too much in California. Another feed that is very important for dairy cattle that isn't considered to be a roughage is silage. So right now, actually in September, we do the chopping of the silage. We pile it in huge piles or a pit, and it ferments and it's preserved that way, just like pickles are fermented and other kinds of foods like yogurt that you eat. So the fermentation prevents silage from rotting, and that is a very good nutritional substance for ruminant animals that digest fiber. And you can oftentimes recognize the silage because it's covered, the top is covered, and a lot of times they put tires on top of it to keep the air and the moisture out. This is a great picture of just a grassy pasture. Remember, one of the biggest advantages of ruminant animals is they can eat low quality pasture and forage that's relatively indigestible to non-ruminant animals. And using their amazing digestive system, they can eat this grass and forage and roughages like silage and turn it into high quality protein like meat and milk. Sheep are very good at that also. This is a good picture of sheep that are grazing on something that you might think is very unpalatable looking, but basically this is a field that's been harvested from a small grain, probably like wheat, and the sheep will be put on that field to graze, and the sheep, they have a split lip, so they can pick up the little seeds, weed seeds on the ground, they eat the chaff, they eat the leaves, and then they can actually gain weight on that. So it's crop grazing on crop residue. And that is one thing that sheep are good at. Sometimes we see cattle put out in fields after, say, sweet corn has been harvested and the corn plants are still out there. Cows can eat that. So we take a feed. One of the things that we do with feeds is we have to do an analysis of the feed to see which nutrients it contains, and that's called approximate analysis. So if we take a feed, the first thing we do is dry it, and then we get the dry matter. Obviously, moisture is water, and water doesn't contain any nutrients. The dry matter then it's actually separated into what we'll call ash, which is inorganic matter. Just remember, the ash is like the minerals, and so all kinds of roughage or even concentrated feed has minerals in it, and that is the ash. From that, we have the residue that burns away. It's called the organic material. And organic matter then can be separated through a chemical process into protein, which is like an acid chemical reaction. And we can see how much protein is in a feed and other ingredients. And the non-nitrogenous matter is the other category of nutritional items, which is carbohydrates and fat. And then with carbohydrates and fat, we can break that down into something even more fine-tuned, and that is carbohydrates could be something like, if you think of corn has very little protein. That's about the protein level in corn, actually. And then you have a little bit of fat in the corn grains, but corn is mostly carbohydrates. And then when we render what we call a nitrogen-free extract, corn is about 56%, kind of high-quality digestible carbohydrates, and some of that kernel of corn contains fiber. And fiber, remember, is easily digested if you have a four-chambered stomach, like a sheep, a cow, or a goat. But it's not very well digested if you're a pig or a chicken. Okay. So if we talk about a little bit more about what's in feeds. So one of the things you have to remember is that ash that that occurs after we are separating the individual nutrients is in minerals in the feed. And then minerals are divided into macro minerals, which you need a lot of, like calcium, sodium, or phosphorus, and chlorine. And then micro minerals. Micro minerals are needed in very tiny amounts, but they're essential for the body to function properly. And then if you take the rest of the material, it can be broken down into carbohydrates. Carbohydrates are fibrous or nitrogen-free extract. And nitrogen-free extract basically is the non-fibrous part of the carbohydrates. A lot of the food we eat doesn't have a lot of fiber in it. It's mostly this nitrogen-free extract. And that boils down to basically sugars, simple sugars, starches, and vitamins. And then the fiber can be broken down by some animals, like ruminants, into cellulose or hemicellulose. Fats or lipids can be broken into fatty acids, which are permeable and go into cells and actually provide nutrients. And then there's some other examples of fats or lipids, and then they talk about pseudo-fats or lipids, which are actually fat-soluble vitamins. So I don't know how much you know about nutrition, but I'm fascinated about nutrition, so that's why this topic is going to take a while. So if we take those nutrients, we break them down into their individual components. And one of the things you have to remember is upon digestion, you have like three levels that the food kind of goes through. So you have the gross energy, which is the actual energy. And energy is the amount of calories. That's how we measure energy in calories. So the amount of calories in the food. And so some of that is lost in the fecal material. So when a cow poops, some of that food doesn't get digested. So that gross energy gets winnowed down to digestible energy. And that's what goes into the digestive system and actually is broken down by the digestive system. Some of that is lost in urine, and some is lost in gases. And cows, they have a lot of flatulence. They pass a lot of gas. And that gas leaves the body in the form of carbon dioxide or methane gas. So that is energy that's lost. And then once the food goes beyond the digestive system and actually goes into the body to help the body organs function, some of that is lost in the form of heat. You run at 98.6, cows are about 101 degrees, sheep are about 102.5. So your body has to maintain that body heat, to keep you alive, and then that requires energy. And then what's left, that little bit, notice the squares get littler. What little bit is the net energy that is left after the food is broken down, digested, all the different areas of nutrition are lost. You have feed that is left for maintenance, which is just maintaining your body, or feed that's left for production. And put this in a big perspective. Think of a dairy cow. Think of how much food a dairy cow has to eat in order to produce 8 gallons or 10 gallons or 12 gallons of milk a day. That's what production is. So that is kind of the digestion of food in a little bit of a nutshell. And this is the same thing. It shows a breakdown by the amount of calories that are lost. Remember, we measure energy in calories. Okay, so let's go through the nutrient classifications. I'm pretty sure you learned this back in, when you were in high school taking a health class, or maybe you've already taken a health class. It's a little different in animals, but let's go through the primary nutrients anyway. So proteins, when you think of proteins, you probably think of, meat. Well, if we're talking about a cow or sheep, they're vegetarian, so they have to get protein from other sources. And the good news is they can make some proteins, make some amino acids in their rumen, but they also have to eat a protein, and it's vegetable protein. Carbohydrates are forms of energy, and carbohydrates basically are made up of sugars and starches. Lipid is another word for fat. And then you have vitamins. Vita means life. So vitamins are essential for life. You just need them in tiny quantities. But they are part of enzymes, and they make your body operate properly, as do minerals. And then, of course, the most basic of all nutrients, one that no animal can live without, is water. So let's talk about proteins real quick. Proteins are made of amino acids. Proteins contain nitrogen. You have to remember that. That's an important thing. They contain the element nitrogen. So the element nitrogen is important because you might have heard that if you're talking about plants. What do you fertilize plants with to make them big and leafy and green? You fertilize them with nitrogen. Right. Well, protein contains nitrogen too. We're talking about nutrition. Remember those elements of the periodic table of elements that you learn in chemistry. Those are the building blocks of all life. Crude protein is measured by the number 6.25 times the amount of nitrogen, and that gives us the crude protein. And then crude protein is a measure of how much protein is available before the food is digested. Crude protein before the food is digested. So if you take proteins, we break them into amino acids. Amino acids are classed into two different categories. There's essential amino acids and non-essential amino acids. So essential amino acids have to be provided for in a diet. Essential amino acids in non-ruminants like chickens and pigs are very, very important for production. In fact, in many rations that are fed to pigs and chickens, we will just supplement the necessary amino acid like lysine or methionine rather than giving them the whole protein, because they don't need the whole protein. They just need those two essential amino acids. But it has to be provided in a diet. Cats have a certain amino acid. I think it's threonine. I'm not 100% sure on that, what I say, but that has to be in their diet. Cats are strictly vegan. They're not omnivores at all. So they have to have certain essential amino acids to live, to stay alive. Non-essential amino acids can be synthesized, and that means your body can make them. So your body makes amino acids in different areas, but a lot of the amino acids are synthesized in the intestines. If you are a ruminant animal, ruminant animals can synthesize amino acids in their lumen with the microorganisms that live inside that huge fermentation fat that cows have. So there's your list of amino acids. When you take vitamin D class, you will learn all of the essential and non-essential amino acids. So that's a little bit about protein. Now let's talk about carbohydrates. Carbohydrates are carbs. I'm sure you've heard that term before. Carbohydrates provide humans with quick energy, especially if they're in the form of monosaccharides, which is sugar. So carbohydrates come from plants, and that's why you need to know something about plant science, right? Because even if you love animals so much, really the origin of all food is plants. And the origin of food is the process of photosynthesis. Because photosynthesis takes carbon dioxide in the atmosphere, water, and in the presence of chlorophyll and sunlight can create sugar. And that sugar can be stored as sugar, something that's sweet like a peach or like a grapes, or it can be stored as different forms of sugar that is bigger, like starch, or it can actually form the cellulose and the lignin that trees are actually made out of. So carbohydrates are plant products. Their basic structural unit is sugar. And the simplest, easiest to digest are monosaccharides, and more complex carbohydrates are cellulose. So only ruminant animals can digest cellulose. You cannot digest cellulose, and neither can a cat or a dog. They might eat it, but they cannot digest it. Okay. So I'm almost out of time. My 15 minutes has almost started to stop. So I'm going to stop here, and then I'm going to start another